Okay, this is part 3, Unit 12D, and in this question we're kind of piggybacking off the question we had before. We're looking at if districts were drawn randomly with the given state, what would be the most likely distribution of the House, and if they could be drawn without restrictions, what would be the maximum and minimum number of Republican representatives who could be sent to Congress. So in this case we've got a state that has 15 representatives. Population is 7.5 million. Party affiliations, 20% are Democrats, 80% are Republicans. And so we want to find out, first, what would be kind of the ideal or the theoretical distribution here. And that for Republicans, that would just be 15 representatives times 80% is what we'd anticipate, which is 12. And then for Democrats, we shouldn't say we'd anticipate this, but this was if everything was randomly put together and selected. Democrats, there are 15 candidates times 20%, which is 3. So those are what would be anticipated if it was everything was randomized. Now, if we allow any districts to be drawn in any way, what's the highest amount of representatives that the Republicans could have, and what's the minimum amount that they could have? So what we're going to do first is we're going to take the 7.5 million and we're going to divide it by our 15 representatives, and that's going to be about it is going to be 500,000 people per district. If we have an even distribution, again, part of those laws are to try and get it as even as possible for every district, so 500,000 people per district. So in order to win, we need, you need half the votes and then one more. So we need 500,000 divided by 2, which is 250,000 plus 1. So you need 250,001 votes or people to vote for you here. Okay, now with knowing that information, we need to find out, how many Republicans or how many seats the Republicans could win. So we take the Republicans are 80% of the 7.5 million. So we're going to take 80% of 7.5 million. Again, that's going to tell us the number of Republicans possible, and then we're going to divide it by the minimum number of votes we need to win a district, which is 250,001. So this is 23.99, and if I round down, that's 23. So there's potential that they could win. There's a distribution here where they could have 23 different districts with 250,001. Well, we only have a maximum of 15 representatives, so the max here is going to be all 15. There's a possibility for these to be drawn so that they win all 15 districts. Now, to find the minimum, what I want to do is I want to find the max for the Democrats, and then we're going to subtract that number from 15, and that will give us the minimum for the Republicans. So in this case, there are 20% Democrats times our 7.5 million divided by 250,001. So this will tell us how many they could potentially win, which is 5.99. So rounded down, so they didn't quite get to 6, rounded down. The maximum that the Democrats could win is 5 in this case, with their 20% people voting or having the party affiliation of Democrat. So it's down, we round down to 5. So the minimum for Republicans will be, we take 15 and we subtract the maximum number that the Democrats can win, and that's going to be 10. So the minimum number of representatives is 10, the maximum is all 15. So that's how we would determine the maximum and the minimum number of representatives. And hopefully you can see that, minimum of 10 out of 15. I mean, 80% of the population voting for one party, you're definitely going to have a significant control in your House, no matter how you draw those maps. So if you have any questions on those, please do not hesitate to let me know. That gives you a couple examples, but hopefully that process makes sense. Okay, now this last one we're going to look at drawing districts. So each little house here represents a Republican voter or a Democratic voter. And so we've got a picture here, state with 64 votes that needs to be broken into 8 districts. The voters are half Democrats, half Republicans. So when I look at this picture here, 32 are Democrats, 32 are Republicans. And we're making the assumption that the district boundary lines must follow the grid lines, and each district must be contiguous, meaning that you can't break them apart. Like I can't say, this district 1 is going to be, those 2 corners right there. They've got to be touching, and they've got to follow the grid lines. And so, as you follow the grid lines, you can't do diagonals like this and say there's 4 and then here's 4 more. You can't do something like that because that's not following the grid lines. So those are our restrictions there. So you want to draw boundaries expected to result in the election of 4 Republican and 4 Democratic representatives. So here's a couple of ways we could do this. We could just cut them so that we have horizontal here. So we'd have kind of 1 district, 2 districts, 3, and then 4. So each of these, 1 row is going to be a district because there are 8 voters you can count in there. So if we look at it, 1, 2, 3, 4, 5, 6, 7, 8. So then if I look at the top, the majority for the top one is Democrats. So Democrats would win that one. Then the next one is Democrat again because there are 5 Democrats there. Then the next one is Republican. The next one is a tie. And so that automatically throws out this redistricting because then you would get Democrats, Republicans, but we don't have exactly 4 and 4. We've got 1 that's got a tie or it's even, so we can't go that route. So that's not going to work for us. So we're going to scratch that thought. Okay, the next one that I could do is again, I'm trying to break these up into groups of 8, but they have to be touching. You can't split these things up. So to get 8, I could break it into this. So here's my first, then my second, then my third, and then my fourth, and so forth. So each of them are kind of broken up into these chunks right here, and that would go all the way through. Let's see how this would go. So this top left one here, that would be a Republican because there are 5 out of the 8. Then we have Republican again. The next one would be Republican. Then this one would be Democrat. This would be Republican, Democrat, and Democrat. And so we have 5 Republicans and 3 Democrats there, so that's not going to work out. So that's doing what we'd call kind of 2 blocks horizontal and 4 blocks vertical. That didn't work for us. So the only other possibility I see is if we were to break them kind of going this way. So I'm going to break them into 4 wide horizontally and 2 high going vertically. So you've got, 1, 2, 3, 4, 5, 6, 7, and 8. So in the first one, you have Republicans 5-3. The next one, you've got Democrats 7-1. Then we got Republicans, Democrat, 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 and then the whole bottom is stacked Republicans. But notice that gives us 4 Republicans and 4 Democrats. So that's a drawing where we follow the boundary lines that will result in 4 Democrats and 4 Republicans. So that's 4 blocks wide, and that's going horizontally. So it's going in the horizontal direction, and 2 blocks high, which is going vertically, and that'll get it for us. So you do have to play around a little bit and make sure that you're able to meet the parameters exactly. Whenever you see those ties, then you can't toss a coin there. You just have to say, that doesn't go to either side. So, but again, just a little bit of trial and error as you're doing these to try and find out, the boundaries, if they can be drawn. Sometimes they can't be drawn as well, and so it takes a little bit of time to break them up. But remember, everything has to be touching. You can't break up, corners or a middle and a corner or anything like that. So that ends Unit 12D. If you have any questions, please don't hesitate to let me know.